We're going to go over section 1.4 in your BJU Press Precalculus textbook. And this section is all about right triangle trigonometry. So what we're going to talk about and learn to do today is we're going to learn what is involved when we're talking about solving right triangles. We also want to be able to solve word problems that involve right triangles. So to solve a right triangle, we need to be able to find the measures of all the sides and all the angles. So there are 3 angles in a triangle and there are 3 sides of a triangle. So to solve a right triangle, you should have 6 answers. You should have every single angle and every single side. Now usually one of the angles will always be given to you because it's a right triangle. So you know that one angle will always be 90 degrees. So let's look at an example. In this example, we want to solve this triangle ABC. And look what they've given us. Of course, they've already shown us that angle C is 90 degrees. And they've also shown us that angle B is 42 degrees. So the only angle that we need to solve for is angle A. When we're looking at the sides, they've given us that side A is 3. How do I know that this is side A and not side B or C? Well, because remember the sides correspond to the angle they're across from. So if this is angle A, across from angle A has to be side A. So that's not how I know that this side is side A. And side A is 3. However, they did not give us side B or C. We have to solve for those 2 sides. So solving a right triangle requires the Pythagorean theorem, a squared plus b squared equals c squared. It also involves using trigonometric ratios. To solve a right triangle, you must find the measures of all the sides and angles. So if this is our example, the first thing we need to think about, well, what is the measure of angle A? Well, we know that the entire triangle is 180 degrees. And we know that angle C is 90. And so if angle C is 90, that means that angle A and angle B also have to be 180. They had to be 90. So angle A and angle B have to add up to 90 degrees. So if these 2 angles have to add up to 90 degrees, that means if we need to find angle A, all we have to do is subtract angle B from 90 degrees to find out what angle A is. So the measure of angle A is 90 degrees minus the measure of angle B. So again, the reason that we're subtracting the angle of measure B from 90 degrees is that angle A and angle B have to add up to 90 degrees because the entire triangle is 180 and we already have 90 of that 180. Well, since the measure of angle B is 42 degrees, now we do 90 minus 42, which is 48, which means the measure of angle A is 48. And we can check that. 90 plus 42 plus 48 is 180, which is what all 3 angles in a right triangle have to add up to. Now, let's try to look at solving for a missing side. When you're solving for a missing side, you always want to start with an angle that's given to you first. So for example, in this one, we solved for angle A, but they had given us angle B. So when I pick what trig ratio I'm going to use, I want to go ahead and make sure that the degrees that I use is 42 degrees because that was already given to me. So I know that I'm going to use 42 degrees. The second thing when setting up your trig ratio is you want to pick a side that's unknown and pick a side that's known. And the side that's known, you want to make it a side that it's already given to you in the initial problem. So a side that's unknown, I could either pick B or C. For right now, I'm just going to pick B. And the side that's known is 3, which is adjacent to 42. So I'm looking for B, which is opposite of 42, and 3, which is adjacent to 42. So I think what trig function is opposite and adjacent? Well, tangent. So tangent of my angle, which is 42 degrees, is opposite over adjacent. So I can write that. Tangent of 42 is B over 3. And I'm going to solve for B using some algebra. To solve for B, I'll multiply both sides by 3. Now I have 3 tangent 42 degrees. And then I can use my calculator. I can plug in 3 times tangent of 42 degrees. I want to make sure that I'm in degree mode. And then I get approximately 2.7. We're always going to want to round to the tenths place, so 1 decimal place after when we're solving for sides. So now I know what side B is. Now let's look at side C, right? So side C is the hypotenuse. So again, remember, we want to start with what's given to us. We're given 42 degrees, and we're looking for something that's missing. We said we're going to look for C, and then something that's given to us, which is 3, right? Which is the adjacent side. So we need a trig ratio that deals with a hypotenuse and an adjacent side. Well, the trig function that deals with adjacent and hypotenuse is cosine. So cosine is adjacent over hypotenuse. So cosine of 42 is the adjacent 3 over the hypotenuse, which we don't know yet, C. So now I do need to do a little bit of algebra to figure out C. So you can set up a proportion and cross multiply, or you can multiply both sides by C and then divide by cosine of 42, but you should end up with 3 divided by cosine of 42 for solving for C. Okay, and then you can plug that into your calculator. 3 divided by cosine of 42 degrees, make sure that you're in degree mode, and you get 4.0. The reason that 0.0 is important is because, remember, we rounded to that tenths place. So 4.0. So now we're going to recap everything that we solved for. Again, you want to write out all 3 sides and all 3 angles, even the ones that they gave you, because solving a right triangle is getting all 6 of these answers. So if you think about it, you really got 50% of these answers right just by being able to look at the triangle. So take hope in that no matter what, you should be able to at least get the ones that are given to you in the right triangle. So side A was given to us, it was 3. Side B is approximately 2.7 because we rounded and we solved for that one. Side C is approximately 4.0. Angle A we solved to be 48. Angle B they gave us, it was 42. And angle C was 90. All right, so let's practice again. Angle B. So we know that angle C is 90, and that angle A and angle B had to add up to 90. So if we need to know what angle B is, all we have to do is subtract angle A from 90. So 90 minus 33 gives us 57. Now about side B. So remember, we want to use the angle that's given to us first, so 33 degrees. And our unknown is B. So now we need to identify a known side. The only side that I see that's given to us is 2.8, and since that's across from angle A, that means that is side A. So we have opposite over adjacent, which is tangent. So we want tangent. Oh, you know what? They used the 57, which is down here. That's completely okay to do. I don't like to recommend doing that because let's say you messed up on simple subtraction, then that means that you got that problem wrong plus these two problems wrong, right? But we'll go with it. It's completely okay to use that angle as well. So if you're looking at 57, which is down here, B is going to be opposite and 2.8 is going to be adjacent. So tangent of 57 is opposite B over adjacent 2.8. So now when we solve for B, all we have to do is multiply both sides by 2.8. So B is 2.8 times tangent of 57. In our calculator, that tells us that is approximately 4.3. Now, for side C, let's see if they continue. Yeah, they're going to continue using cosine 57. Or they're going to continue using 57. So 57 is here. And we are looking for side C, which is our hypotenuse. And we are given our adjacent side. So adjacent on hypotenuse is cosine. So cosine 57 is 2.8 over C. So now we use some algebra to solve for C. We can multiply both sides by C. Then we would have C cosine 57 equals 2.8. Then we would divide both sides by cosine of 57. And we get C is equal to 2.8 divided by cosine of 57, which in our calculator gives us approximately 5.1. So here's a sum of all of our answers. You definitely want to do this on your answers whenever you do the problems because you're going to have so much work all over the place that it's going to be hard to locate your answers. So I would recommend you writing all 6 of these answers in a little box at the end just to streamline that process. All right, so let's talk about some useful definitions for when we look at word problems. We have something called the angle of elevation, which is the angle formed by a horizontal line and the line of sight as the observer looks at an object that is above them, above the horizontal. So when you're looking up at something, that is the angle of elevation. So here's the horizontal, here's our line of sight, and this is our angle of elevation. We also have something called the angle of depression, and that's the angle that is formed by a horizontal line and the line of sight as the observer looks at an object that is below the horizontal. So we have a horizontal and we have someone looking below that horizontal. So here's our horizontal, here's our line of sight, and that's our angle of depression. So let's look at an example. There are 2 lifeguard stands that are 100 meters apart on a north-south coast. So if I were to draw this, I would draw a vertical line that represents my north-south coast, and I know that vertical line is 100. One guard spots an oil derrick at a bearing of south 42 degrees 40 minutes east, so southeast. If the oil derrick is due east of the other guard, how far is it from the second stand? So this gives us an angle, and we need to know how far is that oil derrick from the second stand. So we're talking about something that's east, right? East. So if I were to draw on my triangle, I know that oil derrick is somewhere off to the right side of my triangle. There, like this. Okay, so here we go. Here is my first lifeguard, my second lifeguard. Here's my lifeguard seeing an oil derrick at 42 42 degrees, 40 minutes, right? So he's seeing that. That's his angle. That's the angle right there. And we need to know how far is this oil derrick from my second lifeguard. Okay, so here's our unknown, our x. So using our right triangle trigonometry, if this is our angle that's given to us, and we need an unknown that's opposite, and we're given a side that's an adjacent, well, opposite over adjacent is the cosine ratio. So cosine of this angle, 42 degrees, 40 minutes, equals opposite, which is x, over adjacent, 100. So here's our problem here, set up. Now to solve, we multiply both sides by 100. Remember that 42 degrees, 40 minutes, before you can plug that into your calculator, you do have to convert that. So it would be 42 plus 40 over 60. And then you take the cosine of that, and then you multiply by 100, and you would get approximately 92.2 meters. And that's how you would solve for that word problem. So let's review on how to solve a right triangle. So if you have a right triangle and you're given two of the sides, all you have to do to find the third side is use the Pythagorean theorem. Then once you have the two given sides, you can find out one of the acute angles. Okay, so this involves a little bit of calculator work because you have to use your inverse trig button on your calculator. So for example, if you've gotten the two sides 1 over 2 and you needed to find one of the angles, well, if that 1 is opposite and that 2 is adjacent, that is going to be your tangent. So tangent of some angle is 1 over 2. So remember we talked about using your calculator, and if you put inverse tan or second tangent 1 over 2, it's going to give you the angle that you're missing. And so you have to be in degrees in order for that to work. So then you subtract the angle that you found from 90 to get your other acute angle. Let's say you have a right triangle that has an acute angle and a side. This is like the examples that we've done so far. You subtract the given acute angle from 90, and that gives you the other acute angle. Then you use an acute angle, the given side, and the right trig ratio to find the other side. Then you repeat step 2 to find the third side. All right, that's the finish of the recap.